Hi everybody, and welcome to this OpenStack.Ninja YouTube channel video about infrastructure as code, something slightly different today. So infrastructure as code is something that I hear a lot of people talk about, and I've spoken to some people and they've been confused by it. So I thought I'd just take a few minutes to very quickly talk about what infrastructure as code is to me, and show you a worked example. So first off, what is infrastructure as code? So infrastructure as code usually takes the form of a declarative language, which you then use to describe an environment. Now, what do I mean by that? So imagine you have a server that you want to build on your hyperscaler of choice, so AWS, GCP, Azure, and you don't really want to have to log into the console to build it. So you could use a tool, something like Terraform, to describe that instance in a language that you understand, usually YAML, and that the tool that you're using understands in order to go and build that instance for you. So it's a declarative language. You tell you tell the application that you're using what you want your infrastructure to look like, and it will go away and it will deploy that for you. So it's an automated way of deploying all types of infrastructure. It can be used to deploy bare metal. It can be used to deploy cloud instances. It can be used to deploy virtual instances on VMware, on OpenStack, on AWS, on Azure, pretty much anywhere. There's a provider for one of the tools in order to do that. And as I said, there are loads of IaaS tools, well, infrastructure as code tools around. They all have their own strengths and weaknesses, and they very much all have a cult following. So you will always find people who are very opinionated as to which tool you should use. I, for instance, am a huge fan of both Terraform and Ansible, but as I said, they have their own strengths and weaknesses. Terraform is very, very good at provisioning those instances, getting them deployed, getting them stood up on the hyperscaler of your choice, or as a bare metal, getting them deployed and running. But it's not very good at doing anything kind of second stage. So it's not very good at, say, installing packages or managing package state, which is where you could use something like Ansible in order to kind of log on to that machine and actually run some commands and do some stuff. So there are loads of tools available. This demo and the stuff I'm going to work through here is going to be done with Terraform and Ansible. But like I say, if you go away and search for infrastructure as code, you'll find hundreds of tools. There's SaltStack, Puppet, Chef, Ansible, Terraform, and then you've got kind of the ones that come with some of the services. So OpenStack, for instance, has Heat, which is an infrastructure as code tool that's built in. AWS has got CloudFormation, so there are loads and loads of them. So go away, do a bit of reading. But generally, infrastructure as code is a declarative way of telling a service what you want your services to look like when you deploy them. So why would you use infrastructure as code? Why would you decide to stop building your machines manually, stop editing configuration files manually, and actually, start doing this in a kind of infrastructure as code way? First off, generally it reduces your time for deployment. So if you think about scale, a lot of these tools are designed to fix scale problems. So if you're going away and you're having to build 50 web servers to serve your web application, being able to kind of write a declaration of what that web server looks like, what packages need to be installed, what networks it needs to be installed on, and all the other stuff that goes with it, whether or not you want it to have what image size, what image you want it to use, etc., all described in code in an easy to read and easy to understand for you. Then you push that into the tool, and the tool goes away and does that for you. Now, that's not to say that your first deployment may take a bit longer, because you may need to learn the tool. You may need to go and learn Terraform or Ansible or whatever you decide to use. But it does mean that going forward, any changes you make, you can make them to the code base rather than having to log on to each server and make those changes manually. So the second point is that it massively increases the accuracy of your deployments. Now, again, if we talk about scale, if there's one of you, you're building a single server, there's probably, you may decide that there's no need to use an infrastructure as code tool. you may find that it's quicker for you to jump on AWS's GUI and throw a machine in and log on to it and write your config files and etc. But when you think about scale and you think about having 50 machines and maybe 25, you've got 50 machines that are web servers and you've got 3 web admins. Now, those web admins could all have slightly different ways of doing things. So when somebody asks for a change to be made, web admin 1 goes and does the change and they do it one way. Web admin 2 goes and does it on 10 or 15 machines and does it another way, and web admin 3 does it a third way. The state of your environment is then unknown. So, when you come to make another change on top of that, you may trip over the change that somebody's made before you. So by using infrastructure as code and designing and building kind of a declaration of what you want your environment to look like, everybody knows what the environment looks like because they can see it in the code. And everybody's assured that that's what the environment looks like because people shouldn't be making manual changes to the boxes. So you very quickly get to a point where changes are de-risked and your infrastructure is more stable because of that. So instead of tripping over each other's work and that kind of thing, you're in a position where everybody knows what the state of the infrastructure is, and thus when they go to make a change, your change management process is much simpler because you haven't got to go and do a whole lot of testing up. You haven't got to go and do like a whole lot of checking up front to make sure that somebody hasn't fiddled with X, Y, and Z. So following on from that, if you've got an infrastructure as code base and a declarative example of what your environment looks like, and you've variabilized it and you can make changes to it, you very quickly allow the creation of dev and test environments that mimic your production environment because they're using the same code to deploy, but maybe they're just deploying with smaller instance sizes or less machines. So again, very, very quickly, the work that you would be doing, and so a developer comes along and goes, oh, I need a copy of it, I need you to recreate production for me in a test environment because I need to test this change. Well, instead of having to go and rebuild all those machines manually and kind of remember what the configs look like and all that kind of stuff, you just point your infrastructure as code tool of choice at a new environment and you make the changes to that code base that you need. So you reduce the number of machines or you change the instance sizes, and then you run the commands, and suddenly there's a new environment for that developer. So again, you can very quickly see that it quickly increases your productivity of developers. You can go as far as allowing the developers themselves to go ahead and deploy these environments. If you're using something like Terraform, and that code base is checked into a repository, they can do git check out, Terraform apply, and away you go. If you tie your infrastructure as code tooling with a high quality CMDB, and CMDB is where you store the personality and everything, then you know exactly what your test, dev, and production environments look like. So again, it's about reducing the changes that happen and the changes that damage environments because they've been made and they've not necessarily been tracked properly. And again, it should eventually remove the need for manual changes. Now, I'm not saying that every infrastructure as code deployment that is ever done, nobody ever logs onto a box and makes changes. That's kind of where you want to get to. But as long as you follow and you've got tight process, so if you have to go on and make a manual change, as long as you come back and you update your configuration for your infrastructure as code to match, you don't let it get out of sync. You're in a good place. So kind of that's why I would recommend using infrastructure as code. It solves scale problems, it solves accuracy problems, reduces failure rates, it increases productivity for other teams. Okay, so that's kind of the spiel as to why I would use infrastructure as code. Now let's think about infrastructure as code, and we'll work through an example. So this will lead into a demo. So here we have a simple WordPress example. So WordPress, it's ubiquitous on the web at the moment. Everybody using it and misusing it. Generally, what you end up with is, somebody builds a WordPress box, and it's a Linux server running whatever, Ubuntu, CentOS or CentOS Stream. And they'll install Apache, they'll install PHP, they'll install MySQL, and there you go. You throw the WordPress code onto the web server, serve it up, and you're there. So when you think about this, you've got to build the Linux server itself first. You've then got to do a package update, get everything up to date, get everything nice and secure. Then you'll install Apache, you'll install PHP, you'll install MySQL. And then you've obviously got the requisite configuration files that you need to go through. So you might need to go into Apache, mod enable SSL, that kind of thing. You might go into PHP and into the PHP ini file and adjust the max upload size, etc., etc. Now, when we talk about infrastructure as code, we talk about those scale problems. This doesn't seem like a problem. This is something that a Linux engineer or a web dev can jump on a machine and can do, and can probably replicate that over and over again as many times as you want. Now, if we move on to the needlessly complex WordPress example that I'm going to show you. So here we go. Here's a needlessly complex WordPress example. So now imagine that you've deployed that single box out, and the site that you're running has been absolutely smashed with traffic. You're the next big thing. A single box isn't going to cut it. Somebody comes back to you and goes, well, we need to expand everything. We need everything to be bigger. So you sit down and you think, okay, well, first thing we'll do is we'll put a load balancing pair in front, which is at the very top here on the diagram, and then we'll build 3 web servers. We'll take the SQL service off of those web servers and we'll put those into their own boxes. And then how are we going to manage WordPress's how are we going to manage the replication between the boxes for WordPress? You don't want to have to go around each box and manually update it. So I'll tell you what, we'll deploy Gluster, which is a shared file service. We'll mount the Apache, we'll mount var HTML, var www.html on all 3 servers onto a Gluster cluster. We'll put a MariaDB Galera cluster in for multi-master database read and writes. And now what you've got here is you've gone from a fairly simple kind of construct to a quite more complicated construct. You've got 2 pairs of load balancers, you've got 3 web servers, you've got 3 SQL servers running as multi-master, and you've got 3 Gluster servers serving the web host. Serving the file content. Now you look at this and you think to yourself, wow, I've got to build 3 of those. I've got to build 3, 6. I've got 9 machines to build. They all need the same config. I don't want to have to log on to each machine and do it manually. And this is where infrastructure as code really starts to come into its own. So very quickly, what you can do is, using infrastructure as code, is you say, right, okay, well let's think about this. So first of all, I need to build a web server. What does that web server need on it? Okay, well that web server is going to need to have Apache and PHP installed, as well as all the prerequisite packages. Cool. Okay, so you would go and declare a web server. So you would go into, I'll show you this in a minute in Terraform. You would declare a web server, and you would say, I want this web server. This is what I want that web server to look like. I want it to have 4 vCPUs and 8 gig of memory. And then I want to run the following packages on it. And you build it up like as a structure. And again, I'll show you that in a minute. The one thing missing from this diagram is the Bastion host that I used to actually build the rest of this infrastructure. But what we're going to do now is, if we can keep the diagram in mind, we'll head across to a live Linux terminal, and I will show you this this construct as it is, but actually in Terraform and Ansible. Okay, so we've moved across to a Linux terminal, and what I'm going to show you now is a Terraform based representation of the design that we had just now in the PowerPoint presentation. So Terraform is a tool which can be used with most of the large-scale providers, as well as VMware, OpenStack, Rev, and a couple of other things. And as I said, you define what you want your deployment to look like in a declarative language. Now, I'm not gonna I'm not going to give you a tutorial on how to use Terraform and then how to use Ansible. There's plenty of people that can do that and much better on YouTube. But what I am going to do is kind of show you how I built up that design, and then we'll run the Terraform and we'll watch it deploy the service for us. So I have a directory here, Terraform, and it contains a group of files that end TF for Terraform. Now, Terraform by default expects there to be a file called main.tf, and so I've got a main.tf, and then I've got files for each of the individual pieces that we're going to be building. So for instance, you can see here that there's a file for the bastion, there's a file for the external load balancers that was at the very top of the thing, of the diagram. We've got the Galera load balancer, which is what was called the internal load balancer in the diagram. We've got the Galera hosts, we've got so that's the MySQL servers, we've got the Gluster hosts defined, we've got a template file, we'll come back to that momentarily, we've got a variables file, and we've got a web hosts file. So let's have a quick look in the main Terraform file. So in here, what we're doing is kind of the very, very initial setup of the OpenStack environment. Now, if you haven't used OpenStack before, don't worry. Generally, when you get given an OpenStack project, it's completely empty. There's no network connectivity to the outside world. It is just an empty environment, and I can show you that here. So here we are. The services are very kindly provided by UK Cloud, who is my employer, and allow me to use some of our demo equipment to make these videos. So thank you to UK Cloud for that. But as you can see here, this is an empty OpenStack project. There's no instances, there's no CPUs, we've got no floating IPs, we've got a single security group which is default, but there's no networking in here. You know, it's all very empty. So, you know, as a magician would say, nothing up my sleeves here to show you. But what we're going to do is we're going to take this and we're going to build out the service. So, okay. So what we're doing here is at the very beginning, you can see we're just telling Terraform that we need to use the OpenStack provider. So that basically opens up the ability for Terraform to speak to OpenStack and for it to be able to converse with OpenStack, the OpenStack APIs, in a way that it understands. So you're sending the correct commands. The very first thing we do is we build a layer 3 router. We then build an internal network which we're going to attach all of our machines to. That network obviously requires a subnet, which we then build. We give it some DNS name servers. So again, this is what I mean by declarative. We're saying I want an OpenStack router. I want that OpenStack router to be called the internet router. I want it to be attached to this external network, and we'll go back into the variable files in a minute and we'll see that. So anywhere you see something like var dot, I'm saying this is a variable defined elsewhere, use that. We then need to create a connection between our internet router and the network subnet that we've just created. So as you can see, a lot of this kind of steps down through itself. Now, this isn't perfect. I'm sure people that are much better at Terraform will be along shortly to say that you know, I should be declaring depends on and all that kind of stuff. Yes, I should be. Again, this is just a quick demo. Then as we move down this file, we create some security groups. So OpenStack uses security groups rather than kind of edge firewalling. So each machine, each instance is given a firewall profile. So what I've done here is we've created a security group called SSH, which amazingly allows SSH, one for web for port 80, and one for 3306 for SQL. So that's the main file. Now that file is used first and then is run. So what Terraform will do is it will inspect all of these TF files, go away and actually start kind of building a hierarchy and dependency tree. So if we then have a look at Bastion, so the Bastion server is the server that we actually attach to, and we then deploy all the Ansible stuff from which we'll show you later. So for instance here, what we're saying is that the bastion, in order to be accessible from the outside world, needs a floating IP address. We need to get that from the internet pool. Then the next thing we do is attach that, we associate that floating IP to the bastion host. And then here is where we're actually instantiating the first instance in this platform. So we say it's an OpenStack compute instance v2. This is the Terraform name for it. So whenever we want to reference this instance here, this Terraform instance, sorry, we call OpenStack _ compute _ instance _ v2 dot bastion. We give it a name, so that OpenStack gives it a name. Give it a flavor ID. Again, you can see that VAR, which we'll come back to. We tell it what key pair to use. We tell it which security groups to use. So the security groups that were created as part of the main.tf file, we're referencing the SSH one here. We give it a block device, which we're saying build from a certain image. And again, you can see here that we're variabilizing image ID. So we go and get that. We're saying that we want to turn that into a volume. We're also saying that if we delete this instance, we want to delete this block device. Again, so you can what I'm trying to show is that very quickly you can build quite complicated environments, but the actual language used to build it isn't that complicated. And obviously we then say we're going to connect it to a network, and here we're going to connect it to the name internal network, which is the name of the network that we created in the main.tf file. Now, as I said earlier, here's those depends on. So what depends on does is kind of give Terraform the ability to do hierarchy. So you can't build this instance if the internal subnet is not created, because there's nothing for it to attach to. And again, you can't build this instance if the security group for SSH isn't created in OpenStack, because without that security group, it can't be applied here. So this would actually fail out. So anywhere that you see depends on, again here, so this is the floating IP address that we're attaching to the bastion host. We're saying you need to wait for the bastion to have been created, and you also need to have waited for the internal network to have been created and the OpenStack router to have been created. So until those conditions are met, it won't actually build this bastion. It won't actually try and do this as a floating IP association. So there we go, cool. Well, we won't go through all of this stuff, but what we will do is I'll show you some of the more interesting stuff. So let's take a look at web hosts. So web hosts here is fairly straightforward, layout again. And if you think about it, it looks very, very similar to the bastion host. And in fact, it is. All we're doing is we're saying that we want to create another instance of OpenStack Compute Instance v2. This one's called web hosts. Now, the difference here is that we're saying that we want to give it a name, and then you might notice that what we've got here is we've got like a $ curly brace count.index. Now, what we're doing here is we're actually passing this count variable here into this naming convention. So what in Terraform, when you pass in a count, and you can pass counts into most things, it's a loop. So what it's going to try and do is it's going to create 5 instances of this OpenStack Compute Instance v2 web host, and then it will name it web-0, -1, -2, -3, -4. So it will create 5 instances on OpenStack named web-0 through 4, and they'll all be separate instances. But this is very clean. You don't have to worry about a for loop or a while loop or a count loop or anything like that. It just does it for you. Again, you can see here security groups. We're applying the SSH and the HTTP security groups. Obviously the HTTP security group, because we're going to be accessing this via HTTP. The rest of this is very similar. Again, we wait for, we're asking that this resource is not built until the internal subnet is built, the SSH group is built, and the web security group is built. And again, in the middle here, we've got a block device. So I'm just going to make a change here. I'm going to change that back to 3. Okay, so that's kind of, we could go through the other the Galera hosts, etc., and the Gluster hosts, but they're very similar. All they are is resources, OpenStack, compute instance v2 resources with just some slight changes. What we will do is have a look in variables.tf. So variables.tf is a way of telling Terraform what variables you're either going to pass in or you're going to default. So when we were looking earlier, you know, all of those block device areas, all of these block devices here are calling var.imageID. And here you can see there's a variable called ImageID, which is a type of string, and it's defaulted to this string here, which correlates to an image in OpenStack in the environment that I'm working with. Same for the flavor IDs. Again, you know, so you know, very quickly you can see that when I was talking about dev test environment, you may come in here and you know you've checked this code out to be used for the test dev environment. You come in and you decide that actually you don't want to use this flavor ID because it's too big. You want to use something smaller, so you can come in here and change it. So yeah, there we go. So that's kind of the main bits that make up the Terraform stuff. The only other one that's a little bit interesting is the provisioning Terraform, which we'll have a quick look at. So this is slightly different. In here, we're not doing anything directly with building an instance or you know building a network or anything like that. In here, what we're doing is a couple of things. First of all, we are here we have a new resource that we've not seen before, which is a local file, and we're calling it host CFG. And what we're doing here is we're taking content from a template file, inventory.template, and we're using Terraform's ability to kind of look at objects that it's created and provide that information back. And we're using that for the Ansible inventory file. Those of you that have used Ansible in the past, you know you need an inventory file that explains and with Ansible what you do is you put IP addresses or host names into kind of headings. So you may have like web as a heading, and you put all your web servers underneath that in the hierarchy. What we're doing here is we're saying what we're asking Terraform to do is take this template file, which is basically a group of for loops that just says for this object write this item into the file, and I'll show you that in a moment. But basically we're saying for Bastion, go and get all of the OpenStack Compute Instance v2 Bastion instances that Terraform knows about, which is indicated by the star there. Get the network information, get the first network, and get its fixed IP address. So very quickly you can see that Terraform knows everything about the instances that it creates. And you can use that information to help feed into other tools, and I'll show you that in a moment. But what I'm saying, and then so if we take the web, for instance, we're saying go and get all of the web hosts that you know about that Terraform has created, and get their first fixed IP address, and put those into the Ansible inventory file, and output a file called Ansible inventory host.cfg, and I'll show you that later on. As you can see here, it depends on the load balancer being created, and that's basically so that it's done at the very end once everything's built. And then if we move down here, we've got a slightly different resource. We've got what's called a null resource. So null resources are used for kind of one-shot provisioning and that kind of stuff. So what I'm saying here is I've called it provision services. I'm going to create a connection of a type SSH. I'm going to use the user CentOS. A private key that I've created is here, and you know the host that I want to connect to. And here you can see that ability to kind of interrogate instances that it's already created. So what I'm saying here is go and get the OpenStack networking floating IP v2.bastion FIP address. So if you remember back in Bastion, up here, we asked OpenStack to provision a FIP, so a floating IP address, and then we associated that floating IP address with the Bastion. So we're coming and getting the information from this created resource and using it, here to allow this provisioning service to log in and actually provision the node. So then what we do is we're running inside this null resource, we're then running a provisioner remote exec. Again, not recommended by Terraform, just doing it as an example. And again, you can see we're installing EPL release and Ansible. Then we're copying a file up. So we're actually copying up. We actually copy up the Ansible directory, and I'll show you the Ansible directory in a minute. We then take a copy of our SSH key, private key, and put that on the Bastion host so that it can be used for Ansible to kind of log in and provision everything. And we also we make sure that we set the permissions correct on there. So we come down a little bit further. We then run a provisioner, another remote exec, and this actually runs the Ansible playbooks as one-shot playbooks on the host. And we'll go and look at these now, but we're going to install Gluster. So basically what we're doing is we're running Ansible, we're passing in the inventory, which we'll show you in a minute, and the inventory is split up into the types of servers. So you've got Bastion, Web, Galera, and Gluster, and these playbooks are targeting those individual servers in order to deploy the required services onto them. So you can see here, again, we've got a depends on. We obviously don't want this provisioner to try and run when the servers haven't finished booting or they haven't been finished creating. So we actually say, wait for the association with the Bastion host to complete, wait for the Gluster hosts, the web hosts, the Galera hosts, and that file to have been created before you attempt this run. Underneath that, we then have another null resource, which is a separate provisioner, which is called Provision Services Expand. Now, what this does is it provisions the web servers, but it also allows us to scale the web servers. At the moment, that's the only piece that I've got that's scalable. Again, just a demo, but you get the idea. And what we do here is, we copy up the updated host file, so the updated Ansible inventory file, and then we run a remote exec and we run some Ansible playbooks just on the web servers themselves. So that's everything there. So what we'll do now, before we move on to the demo, is we go back up the directory. In here, we have our Ansible playbooks. Now, Terraform, as I said earlier, is all about the delivery of your infrastructure into your environment. So we want to build networks and routers and attach IP addresses and build servers. What it's not very good at is kind of installing some packages and making sure services are enabled and started and that kind of thing. And that's where Ansible really comes into its own. So we'll start off with the inventory file, which isn't there because we haven't got one created. So we won't start with the inventory file. I'll show you the inventory file later on. So let's start with the very first thing we do in the Terraform, which is installing Gluster on the Gluster node. So I've got two playbooks here that do the Gluster configuration. I probably won't walk you through all of the playbooks. I'll just show you a couple of them. You'll get the idea of how they're built and configured. And the playbooks all follow the same kind of logic. These are fairly basic playbooks. They're not using roles or anything like that. They are simply one-shot kind of playbooks. They're not, so somebody with a lot more Ansible knowledge can look at these and think, these are really basic. And they are, again, just to kind of give you a flavour of what they're for. So if we have a look at install Gluster, so we'll start at the very top. Become yes basically says when you've logged into the machine, do you want to basically run all of these commands as sudo? And what we're saying is yes, we do. We want the Ansible provisioning to act as a super user. Host section. So the host part tells you what servers it's going to run against. And again, once we've got the inventory file, you'll see that there's a section called Gluster. It'll have all the Gluster server IP addresses listed, and this is basically telling Ansible to run this playbook against all of those IP addresses. Name, Gluster install, pretty self-explanatory. And then we get into the meat of the the Ansible playbook, the tasks. So the very first thing we do is we enable EPEL, and as you can see here, we have a task name enable EPL. We're calling yum, and we're passing in the name of EPEL release, which is the package that we want to install, and we're saying state of latest. What that tells Ansible to do is to basically do sudo yum-y install EPEL release. That's basically the command that happens in the background. And that will, as this playbook runs, the very first thing it does is it works through these one after another, and it will install EPEL. We then install a special repository for Gluster. We create the file system on the second disk that we attach to the Gluster server. We create a brick. This is all Gluster stuff. It's not that important, but you can see here I'm using shell. There are better ways of doing it, but shell was the quickest way at the time. We punt something into fstab. We then run mount-a and mount. We create the additional storage area, so it's just creating a directory. Then we install the Gluster FS services, we enable them, and here you go. So you can see here service, so we're calling the systemd, or on something that's not a systemd, an init.d file. We're saying that glusterd enabled is yes, so that would be the same as doing systemctl enable glusterd, and then we start it by doing service name glusterd state started. So again, very similar to Terraform in that you're describing what you want your instance to look like, and you're providing that information to Ansible, and Ansible will then act on it on your behalf. So that's a fairly straightforward one. If we have a look in the configure Gluster, again, fairly straightforward. This just makes sure this actually just finishes off the installation of Gluster. If we have a look at install configure web servers, so what I want to show you in here is that obviously the ability to scale or to increase the number of web servers is controlled by Terraform. We saw that there's that count variable in the Terraform code. Now that obviously brings in some interesting pieces for the Ansible code, and I'm just going to give you a quick overview of that. So basically what we say is, this is to configure the web server with Apache, PHP, and Fuse. So the first thing we do is check if it's bootstrapped. Now, bootstrap to me is that it's already had this process run on it, and thus it's already part of the cluster. Thus, we need to ignore it. And again, whereas Terraform had the kind of depends on, we have a when clause in Ansible. So you can say when it's not bootstrapped. So when the bootstrap file doesn't exist, run this task. And again, as you can see, there's a group of tasks in here that you can see that exists. That's Ansible in a nutshell. It's a group of playbooks, which is what they're called. They're in the YAML format. They take the form of that kind of hierarchy, do this, then this, then this. You can get some quite interesting flow control in there with when statements and facts and that kind of thing. Again, I'm not going to go through that now. So yeah, so that's kind of the nuts and bolts of how the service is designed and built. So I think now what we'll do is we'll actually run the Terraform code, and we'll go from there. Okay, so what we're going to do now is run the Terraform code. I won't sit and watch the whole thing. It takes 10-15 minutes to run, so I'll pause the recording and then come back and we can look at what it's done. So we're in the Terraform directory. Everything's configured as we want it to be. There's a couple of commands. Terraform plan. So what Terraform plan does is it takes a look at all those TF files, and it basically gives you a breakdown of what Terraform is going to do. And as you can see, there's a fair amount of things that it's going to do. As you can see here, it's going to create that local file host.cfg. It's going to create the provisioner services. It's going to create the floating IP addresses. It's going to create the bastion host, etc., etc. So without further ado, let's get back down the bottom here. Hit Terraform apply. Now Terraform We'll always make sure that you want to do what you're doing, because obviously somebody could make a change to a file accidentally and you could run Terraform apply and you could delete something. So always take a look at what Terraform is going to do. Here, because there's nothing there, the plan is we're going to add 38 items into Terraform. Now Terraform keeps a state lock on everything that Terraform has done. It keeps it in a TF state file. We're just going to say yes, and you can see it starts off straight away creating some things. So you can see that here, you can see like it's creating the security groups, creating the network, the internal subnet, a bastion, and the internal router. And now you can see it's gone off to start creating the actual instances. Now if we switch back over to the OpenStack GUI, so you can see that it's got 9 instances. It's using 100 gig of storage. Yeah, some RAM, 4 volumes. If we have a look at the instances tab, you can see that it started to build them, and you can see the flavors are slightly different for some of the machines. But here you can see, when I said about the count, you can see web-1, web-2, web-0. See, it started building. So what we'll do is we'll leave this to run and we'll come back in a few minutes when it's finished. So welcome back. So as you can see now, the Terraform has finished deploying the servers and is now actually doing the provisioning step. So again, you can see it's installing some packages. It's installing Ansible. And what we'll do is we'll just give it a few minutes and we'll watch this run through. We'll watch a bit of the Ansible run, and then I'll pause the recording and come back again once it's finished. So you can very quickly see why this gives you the ability very quickly to build multiple servers, build multiple environments very, very quickly, and without sacrificing efficiency and speed and accuracy. You've got all this stuff built in code, so you know what the service is going to do, you know how it's going to build, you know how it's going to end up looking. You're not guessing that somebody has done something the right way, which is the main reason that infrastructure as code exists, is the ability to ensure that what you're deploying is cookie cutter and can be deployed again and again and again. So here we go, it's now installing Gluster and starting the Gluster services across the 3 nodes, and it's now installing Galera. So what I'll do now is, this is obviously this is the Ansible run. I'll pause the video here and we'll come back once it's finished. So whilst we're going through here, I talked about configuring complicated services. So Galera is a multi-master SQL service. It's clustered. So what we do here, as you can see in this Ansible play, is we're disabling SE Linux. Never do this in production. Learn how SE Linux works. Again, I did this because time constraints. We stopped Galera. We're adding config to the 3 nodes. You can notice that that does it based on which node it's working on. So it does the config on 3 different nodes. It starts a new cluster, then it starts the 2nd and 3rd nodes and brings those into the cluster. Then it continues on with the provisioning. As you can see here, provisioning the web services, etc., etc. We're now at the point where we're installing PHP 7 and the other bits required for running the service. So again, I'll pause here and come back. There's only a little bit more to do. I'll come back when it's fully finished. So there we go. Ansible has finished running. Terraform has finished running. Everything has worked as expected. If we come across here into the OpenStack GUI, we can see that it's built the 10 instances that we're expecting. So you can see here it's built the Bastion host, it's built the 9 other servers as per our diagram. It's come in here, it's built a pair of 2 pairs of load balancers. So we've got here, this is the internal load balancer, here's the external load balancer, and just to prove that it's worked, we come across here. There we go, WordPress installation page, HA WordPress demo. stick a username in. Boop. Click install WordPress. Log in. There we go. A fully working WordPress installation, based on having, based on the design that we had. So if we go into Ansible, I can show you the inventory file now. Again, here you go. So this is the Ansible inventory file that's uploaded. If I then scale Terraform, it would add a new host to the web. In fact, let's do that quickly now. Web host. So we come in here. So we're going to go from 3 to 4. Terraform apply. And we'll sit and watch this. So what it does now is it refreshes the state, checks OpenStack, makes sure everything is correct. Then it says what I'm going to do is I'm going to replace that config file, because obviously it's going to add a new one in. I'm going to rerun the provision of services expand. I'm going to create a new OpenStack Compute v2 instance called webhost 3. Going to create a new volume, add it to the network, and then I'm also going to create a new load balancer member so that it starts serving traffic. So if we say yes to that, and again I'll pause and come back when that's finished. So unfortunately that failed because there's a raise condition. So I'm just going to reapply that. Okay, so now the host is up. There's a bit of a raise condition that where the instance reports to Terraform that it's started, but obviously it hasn't actually finished starting on OpenStack. So just rerunning the provisioning piece. You can see that now the Ansible is only affecting a single one of the hosts, which is our new instance. If we switch back over to here, go back to the instances tab. You can now see Web 3 here, which wasn't there previously. And you can see here that it's working on 10.10.10.19, which is this box here. So it's just finished installing PHP. There we go. So that's now finished. Now if we log into Bastion host, grab the IP. And then if we do we're going to SSH to the new one, which is this one. Now, if you have a look in the access log, you can see that the load balancer is now polling it. And if I come back over here to WordPress, bounce around a couple of times, you can see that it's now serving traffic. So we've gone from having 3 web servers in the web cache to having 4. Obviously, we had the small issue, live demos and all of that. But you can see that has joined the cluster, and it's working. So there we go. So that pretty much finishes my kind of why infrastructure as code and a quick demo. Admittedly, not been that quick. But yeah, so thank you very much for watching. If you have any comments, please leave them in the comment section. I read them all and respond to them all. Thank you very much for watching, and goodbye.